All right. I started writing this and realized the process of looking at it could also be helpful. So let me go back and share screen with us here. Here we have these values. So the first thing that I realized is we display the list. At the end of this code, we need the driver code to test it out, right? So yeah, find the last node on the list is what we need. But when we do find it, we return it, we need somewhere to store it. So I had to declare another pointer for this. So node start, pointer to the last node. The other thing, like if you just return the integer number, you could use it in a cout statement, but we want to have the pointer to that node, right? So we need somewhere to store it. And after we store it, then we could print the last node value is, and we get this pointer to the last node, and we print out the data, and then we have endl. So now we want to go and using what we already looked at, we want to find this last node on the list. So here's find the last node on the list up here. So this is another function. If we're trying to document as we go, we might put a comment, and we might say, return a pointer to the last node on the list, like that. And the first case that we saw was the case up here where the list is empty. This was case one. If the list is empty, in other words, if p head is equal to null, then we're going to just return the value null. So we can put that in there, right? So here, if the head of the list, p head, is null, list is empty, then we just return null. So that's fine. That's pretty straightforward. Second case, list has a single node. So that's if p head arrow p next is equal to null. So we could put this in here. So this might be a third case, right? So this first case would be see if the list is empty. And then the next case would be see if list has a single node. And then the third case we're going to be see if list has multiple nodes. Okay. And this is find the last node on the list. So down here, if we're helping ourselves keep track. All right. So here, see if the list has a single node. Else, if the list has a single node, else if. How do I know if this is true? I have some case here to check this condition. If the list has a single node, and when we looked at this, we saw if the head pointer arrow next is null, so this code right in here, so that's what we want to put, right? So if the head pointer p head arrow p next is equal to null, so there's a node, p head points to something, but its pointer, its next pointer is itself null, then we're going to return p head. So we saw that that's the value that we return, p head in this situation. So here we return p head just like that. And lastly, the last case down here, else there's more than one node. So either the list is empty or has a single node, or there's more than one node, and that's the case that we have here. So if there's more than one node, and maybe we want to put this, since it's commenting a section of code, we'll put that up here like that. So if the list has multiple nodes, we need to find the last one. So we need to traverse and find the last one. And we looked at this. Here we have while the ptemp arrow p next is not equal to null. In other words, while there is a next node, advance the ptemp pointer. Okay. So if we go in here, we can put this in there. Now in this case, we have p head. So I think we talked about maybe changing this to be ptemp, which means this should be ptemp here too. And also down below here. So instead of ptemp with p head, we'll call it ptemp, right? Else, now iterate through the list while there is a next node. All right. So while ptemp arrow p next is not equal to null, while there is a next pointer. So here, then I would be advance to the next node, right? So ptemp is equal to ptemp arrow p next. And this is what we had here. We're using ptemp, right? And then we return ptemp. So already here we can see that we're mixed up a little bit, right? Down here we use ptemp, up here we use phead, so we're at the risk of confusing ourselves a little bit. We should be consistent. These should all be ptemp or all be phead, right? So back to our code. So warts and all, like the development process, our thinking, right? So we advance to the next node, and once we've finished this while loop, we've gone all the way to the end, the value that we return is ptemp. So we need to go ahead and do that here. So we return ptemp, which is the last node. And then we're at the end of the function, and that should be it. Okay, so if we run this now we can test the 3 different conditions when we run this code. So let's go up here and run this program. So here we go, running, and it should prompt us. Thinking. There we go, enter numbers for the list followed by -1. If we look at our test cases, the first one is the list is empty. The list is empty if our input is just -1. So we type in -1. Let me pause for a second and say, we looked at the 3 conditions. We looked at the what it looks like before and after, right? We looked at the condition to identify which of these 3 cases that we're in. What's the value that we return? The other thing that is helpful is to consider what is the input that we would use for each of these cases to test it. So the input here for testing it is just -1. The list is empty. So here, the input that we would use for this case is simply the value 3, making a single node, which gives us this situation, and then we test for it and we return this value, right? So this could be, right, ptemp for that one there, and this could be ptemp here too if we're trying to be consistent, right? And we return ptemp. And then down here, we already are using ptemp, so we're fine with that. And this, we're going to call this ptemp, right? For all of these, ptemp, and down here also ptemp. Okay, so we're consistent. All right. And lastly, down here, what's our input for this case? So down here, our input would have been 3, 5, 7, because we're doing the code for prepend, and then -1 after that, right? So let's test these one at a time. So first of all, let's test this one where the list is empty, where we have the input of -1 up here at the top. So we run this program, and we type in -1 right here, as we see, -1, and last node value is, and it just kind of freaks out. And why is that? Well, because it's trying to print the last node arrow data, but there is no last node. This is null. This is a problem, right? So we shouldn't be trying to print something if there's no node there. And so here we can identify that we have a problem in our code, because here, if I try and print the data value of a null pointer, there is no data value for that. So this identifies that when we, in the driver code, we also have to change something here. We can only print it out if there's a node there. So if the pointer to the last node is not equal to null, then we can call this instruction right here. If it is equal to null, maybe we'd have an else statement there and say, you know, cout list is empty or something like this, right? All right, so we can test this again and see if we fix the problem. So here we come in, we give it a -1 again as input. There's a -1. And, oh, here, oops, put the -1 in the wrong place. Let's start this, and we get the message list is empty. So that's working properly. So let's look at the second test case. Here we have the input of 3. Let's see what it does when the input is 3. So we run it. And we're going to make a list with a single element in it. So it has a 3 and then -1. So single element on the list, 3, the last node value is 3. So it looks like that worked fine. So it went through this situation, got the pointer to this last node, came back to main. Here in main, we receive the pointer to the last node. And then because it's not null, it's pointing to something, we print out the data, which in this case is the value 3. And now multiple nodes. So we'll have the input of 3, 5, 7, and -1. And what we expect is p temp is going to bounce down the line until it gets to the last node, and it again would be printing out 3. So, so let's try that with multiple nodes. So we run it, and multiple inputs, 3, 5, 7, -1, and it prints out the list for us, 7, 5, 3. The last node value is 3. Looks like it's working fine. So just to recap, what we've done here is we've identified, tried to understand the problem. Our problem-solving strategy is understand the problem, make a plan, implement the plan, and then revise. So we made a plan of what it is that we need to do. We tried to break it down into pieces, like eating a bicycle, right? So here the list is empty. And by eating a bicycle, like one small piece at a time, we broke it into pieces. So the list is empty is one case, or the list has a single node, or 3, the list has multiple nodes, and we identified those. And then we tried to break it down further. What does it look like with a picture? And how can we identify this is the situation that we're in? And then what is the value that we return in this situation? And then we identify what would the input be to put us into this situation so we can test it. And then we took this and we wrote the code for it, but we didn't just write it from scratch. We broke it down. We broke the ideas down into individual steps so that we can get traction on solving the problem and don't just have to sort of blindly go and write it. So this is critical with linked list code. Draw pictures of what it looks like. Find the conditions that take us into each situation for each picture. Think about what the input is. Think about like any return values or things, the results of what you have for your code, and then put these pieces together in actual code. Here we had to like change it because we had p head instead of p temp, right? And then go through and test it one step at a time, and you'll identify some errors. Like here we had a problem with the -1 in the driver code, gave us an error. So inevitably, almost always there's errors like this. And then you're done. So we can write it one piece at a time.